Welcome to ClickMyProject.com. Now we are going to discuss about the title a 28nm CMOS 1 volt 3.5 gigabits 6-bit DAC with single independent delta-I noise DfT scheme. Now we are going to discuss about the abstract of this title. A digital to analog converter is a function that converts digital data into an analog signal. An analog to digital converter performs the function. Unlike analog signals, digital data can be transmitted, manipulated and stored without degradation with more complex equipments, but a DAC is needed to convert the digital signal to analog to drive an or loudspeaker amplifier in order to produce sound. This project presents a 3.5 gigabit 6-bit current sensing digital to analog converters with accurate circuitry to assist testing in a 1 volt digital 28nm CMOS process. The DAC uses only thin oxide transistors and occupies 0.03 mm, making it suitable to embedded in VLSI systems. Designed for test standards for IC designing technicals that added certain stability features to be hardware proceed design. The prisms of the added features is that they make it easier to develop and apply manufacturing test for a designed hardware. The purpose of manufacturing test is to validate that the product hardware consists to manufacturing defects that could otherwise affects the product correct function. So tests are applied at several steps in the hardware manufacturing flow and producers may also be used for hardware manufacturing in the environment. So the usage of DAC is rapidly increased in communication devices. Thus this paper presents a design of DAC using delta-I noise DfT schemes. By using this scheme, the conversion process is very speed and low power will be achieved. The communication devices are mostly prefer this type of DAC because this type of DAC increases the process time and lower the power consumption of the circuits. Now we are going to discuss about the flow of this DAC. This flow shows the full operation of the digital to analog conversions. So in this flow, the first module is test assessment. The test assistant block provides the DfT scheme and it also provides the data to perform the digital to analog conversion. Thus the test assessment block consists of CML to CMOS conversion and data ring registers, CMOS to CML conversion and data reconstructions. And then it followed to this 8 cross TI sub clock blocks are consisting. So in the sub clock block, D flip-flops are used to provide the clock input to the enable and align block and to the data. So reconstruction blocks, the clock pulses is given to this block, then the clock pulses are considered as the CML signals. Then the CML signals are given to the CML to CMOS conversion block. By this signal, the data ring registers is selected the sub datas and follow to this enable and align CML to CMOS conversion blocks are used. So in this 8 registers and 8 NAND gates are used to provide sub-clock input to the next block. The serial data are given as input in this block, then the output of this block provides sub-clock signal to activate the next block. Then the enable signal is given to this block as the control signal to activate all the registers and provide subclock output. Then follow to this data ring registers or user. In this block, registers are connected as a ring register. The input clock signal is given to this ring register to perform continuous data output. The data ring register provides the 6 sub data as the output in this block. 8 ring register is used to provide 8 combination of sub data outputs. Then CML to CMOS conversion is discussed. In this block, the CMOS signals are converted as a CML signals for further operations. The CMOS to CML conversion has 8 subclock as input. Then it performs the conversion operation. Then it provides 8 CML signals. Then followed to this data reconstruction block is contained. In this block, the data are reconstructed by using the mux block. It has 2 input and 1 selection line as input. In this data reconstruction, 6 mark blocks are used to reconstruct the given signal depending upon the selection signal. So finally, the given digital signal is converted into analog output. Now we are going to see the design and the simulation results of the digital to analog conversion. For that, the DAC is designed using Tanner software. So first we have to click to this Tanner design. Then the designing program window will be opened. In this window we have to design the DAC circuit. So for that, first we have to design the test assessment block. Then follow to this we have to design CMOS to CML conversion block. Then we have to design D/A switches. Then finally the digital inputs will be converted into analog outputs. Then we have to see the simulation results. So for that we have to run. Then the simulation window will be opened. So in this window, the digital inputs are given and corresponding to that analog outputs are obtained.